workshop number 3 on the topic of data analysis, where my colleague Dr. Tim Hilken will walk you through how to conduct an independent samples t-test in SPSS.
As you likely recall, you'll be conducting an independent samples t-test when you have a dependent variable that is measured on a metric scale, interval or ratio, and an independent variable with exactly 2 independent groups, for instance, males or females, or as in the example of the Marketing Management Week 2 survey data, 2 different grading schemes that were randomly shown to participants. So grading scheme A versus scheme B. And the dependent variable in this case was the perceived fairness of grading measured on a 1 to 5 interval scale. What the independent samples t-test does is it allows you to compare the averages of 2 groups' values on a dependent variable. And the dependent variable, as previously mentioned, needs to be measured at least on an interval scale. So as shown here, I've already plotted this. You can see the fairness ratings provided for the different grading schemes, and what the independent samples t-test allows you to do is to compare whether that average score of 3.76 for scheme A is significantly higher than the perceived fairness of 3.52 obtained for grading scheme B. The prerequisites for this test is that you have a nominal grouping variable with exactly 2 groups, and you need at least 30 respondents for the test to be reliable and valid. And as previously mentioned, the dependent variable needs to be at least interval. If we then go to SPSS to conduct this test, the first thing that's important to do is to briefly check how your grouping variable, the IV, with the 2 groups is coded. In this case, it's the grading scheme, and if we go to values here, we can refresh our memory that we've coded this as a value of 1 corresponding to grading scheme A and a value of 2 corresponding to grading scheme B. This will become important in a second when we conduct the test, which we can do by clicking on Analyze, Compare Means, and then selecting the Independent Samples t-test. What we'll then first do is select the grouping variable, in this case the grading scheme that's presented, and then we hit Define Groups. And this is where the previously the A and B, 1 and 2 value designation becomes important, because here we need to specify that group 1 has a value of 1 and group 2 has a value of 2 in this case. And then we can insert here on the top as the test variable the dependent variable on which we want to compare the 2 groups. In this case, we'll quickly look for the scale here about how fair the grading was. We insert that then here and hit OK. And what we can see here is the output of the test. The first thing to look at are the overall group statistics, where we can again see the means across the 2 grading schemes presented. And as already shown in the bar chart, it seems that grading scheme A is perceived as fairer. But because, and we can see this here, there's some standard deviation around the means and the standard deviation needs to be taken into account to draw a conclusion whether these differences here are statistically significant. And to find out if that's the case, we then look at the lower part of the output, and this we need to analyze in 2 steps. First, before actually drawing conclusions about the means, we need to look at the so-called Levene's test for equality of variances. And this tests an underlying assumption of the independent samples t-test, namely that the groups, A and B in this case, have equal variances. And depending on the outcome of this test, whether equal variances can be assumed or they cannot be assumed, we then in a second step need to look at different p-values. The way the Levene's test works is that you look at the significance value of the Levene's test and then decide whether you have equal variances or not. The null hypothesis in this case is equal variances are assumed, and with a p-value of 0.011, which is clearly smaller than 0.05, we can reject this null hypothesis of equal variances. So in the case here, Levene's test tells us we don't have equal variances, and hence we need to look in this row, the lower row here, for all relevant statistics. If we do that, we can then move on to the second part where it's really about the testing of the differences or equality of means. And in this case, we look at the lower p-value here, which is 0.063, and that is just above the conventional threshold of 0.05. So while it seems that grading scheme A, if we just look at the mean, is perceived as somewhat more fair, we see here that with a p-value of just above 0.05, we don't have enough support to reject the null of equal means and find support for the fact that grading scheme A is statistically significantly perceived as fairer. We could say, however, that there is a marginally significant, so often when p-values are lower than 10%, so 0.10, researchers sometimes talk about marginally significant effects, but then we need to be very cautious and acknowledge this as a limitation. So we could, in sum for this test, conclude that there is a marginally significant difference between the fairness perceptions in the schemes, and we have some small support for the fact that grading scheme A is perceived as somewhat more fair.